All right, so these questions should be some of your easier questions that we're going to handle in terms of, ow, 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 kitty, 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 ouch, claws, leg. Sorry, the cat was kneading my leg and couldn't keep quiet about the pain of needles digging into my skin. Anyways, moving on. On these tics, we're going to calculate the rate of change. Rate of change is the same thing as our slope. That is the change in y over the change in x. And it says we're going to figure that out either tabularly. Yeah, I probably did not pronounce that right. I'm a math teacher, not an English teacher. Anyways, we're also going to look at it graphically or algebraically in context depending on what the situation is and dealing with real world problems. Okay, so we've got a table that's showing a list of average height, feet in trees on a tree farm and the number in years. Okay, so this is x, this is y. The reason that I know that this is x and that's y and not the other way around is because we're looking at height is almost always, there's two rules in terms of your dependent and independent values and your x and y axis. Yes, height can be your horizontal axis. It could be your x value depending on the situation, and there are situations that will happen. But a majority of the situation, your height is going to be your y value. Okay, so those are the little clues. Time is typically going to be your x value. So those are kind of ways that you can denote which one's going to be your, and handle your change in y over the change in x. Okay, so now I want to look at, well, what did I do to get from 1 to 3? I added 2. And it's going to be the same all the way across. Well, what did I do to 10 to get to 24? I added 14. So my slope is going to be 14 divided by 2, which is going to give me 7, which is my answer choice C. My slope, my rate of change is going to be 7 feet per year. So if you were to go all the way across here, the average difference when I change, the average difference in the change is going to be 7 feet. Now we're going to look at this rate of change from a graph. You can look at this using the slope formula, and probably you're going to have to instead of doing rise over run because this is a decimal. So we're going to have to use this algebraically. So you can either start from this point or this point. Either one doesn't matter. I'm going to go ahead and start from 5, 2. So my slope is going to be 2 minus 3.6 over 5 minus 3. That becomes plus. So this is going to be 2 minus 3.6. It's going to give me negative 1.6 over 5 plus 3 is going to give me 8. So 1.6 divided by 8 is going to give me negative 0.2. Since you'd be filling bubbles on the star, you'd end up having to put that as a decimal. So your slope's going to be negative 0.2 instead of as a fraction. Same kind of situation with this question here from 2019. We show a linear relationship between x and y. We want to find the rate of change. Now you could technically sit here and I can say, okay, from 33 to 15, I'm subtracting 18 from it. From 6 to 2, I am subtracting, or rather adding 4. Let's see, negative 6 plus 4 will give me negative 2. So our change in y is going to be negative 18 over the change in x. It's going to be 4. 18 divided by 4 is going to be 4.5. Our answers are not in decimal, they are in fraction form. So 4.5, let's see, 18 divided by 4. 4.5 as a fraction is going to be negative 9 halves, which is our answer choice H. I'm going to do the next one in the next video. Again, I don't want the video